gentlemen. I'm Kong Lingling, a PhD student from the University of Hong Kong. And today my speech topic is when permission blockchain meets IoT oracles, an on-chain quality assurance system for offshore modular construction manufacture. It's an innovative practice of blockchain in the construction industry. And the outline of today's topic involves three parts. Firstly, I will introduce the background by answering three questions. The first one, why modular construction attracts more and more attention in the industry? And what kind of challenges for the quality assurance in modular construction? And the third one is why blockchain and IoT can contribute to solving those problems. Then let's go through the second part, the e-inspection 2.0 system, which is an innovative and feasible solution to achieve remote and trusted quality assurance in modular construction. And the final part is a case study and evaluation, which gives an example of a residence case at the University of Hong Kong and evaluates the performance of the system. Now let's move on to the first part. The construction industry is an essential contributor to the process of development and encounters several challenges, including the high labor cost, the long construction time on site, and confined spaces in urban areas such as Hong Kong, Singapore, and China, and accompanying environmental costs such as the waste, noise, and dust pollution. The modular construction is a feasible construction solution to solving these problems. The typical modular construction involves three primary phases. The first one is off-site or even offshore manufacture of construction components. And then in second cross-border logistics phase, the prefabricated modules and components are transported to the construction site by specific vehicles or ships, and finally assembled at the whole building on-site. It's a distributed and complex processes that involves multi-stakeholders and requires trusted collaboration to guarantee quality. And the traditional digital quality assurance in the modular construction involves three steps. Firstly, an inspection invitation from contractors should be submitted to the client. And then the delegated consultants, such as building service inspectors or registered structural engineers, will do the quality checking activities on site. And then the consultants generate the inspection reports in the form of paper or electronic files. And the final step is client verification and signing of the billing instructions if all the checking items comply with the production standard. However, the COVID-19 changed everything. The strict cross-border control makes on-site inspections being a much more difficult or even impossible task. In this way, the on-site quality inspection can only be carried out by the contractors themselves, which may lead to data loss or even manipulated data, and accordingly, unreliable quality assurance. And that's why blockchain and IoT contribute to the remote QA and bring opportunities. This table illustrates the attributes of a permission blockchain and IoT, and how these attributes contribute to the challenge. A consortium, or in other words, permission blockchain, is a distributed system that guarantees the traceability and the relatively immutability of quality assurance data, and the granted access control function supported by the certificate authority and the membership service provider enables stakeholders of the MC project can only leave or join the network with the authorization. And IoT enables real-time data collection and guarantees the true provenance of data. And in this way, the modular construction quality assurance challenges include data loss and loss of trust, and the strict cross-border control are deemed to be overcome. After talking about the background, by integrating the permission blockchain and IoT devices, the e-inspection 2.0 system is composed of three types. This is a brief introduction. The three tiers are the infrastructure layer, the platform layer, and the service layer. And the infrastructure layer involves backend servers and data storage and computation tools. An open source permission blockchain, the Hyperledger Fabric, and Spring Web Service are deployed on the platform layer. And the service layer provides a mobile-based application named eInstar, which provides QA functions and acts as a media between users and permission blockchain and IoT oracles. And different roles contain different authorities in this app. And the most important part, or the core part, is the transaction workflow. Oh, sorry. So the quality of the workflow of the e-inspection 2.0 system is shown in this picture. The mobile-based application eInstar plays a fundamental role to connect users, IoT devices, and the permission blockchain. The on-site contractors recognize modules by scanning the QR code or near-field communication, and then taking inspection photos by the app, and the recordings will be approved or disapproved by the off-site delegate users, such as the register structure engineers. The photo recording activities and the verification processes between the on-site and off-site users invoke transactions, and all transactions and inspection-related data will be stored in the permission blockchain. And after introducing all the fundamental definitions of the e-inspection system, I will now give a brief presentation of the case study. It's a developed this developed e-inspection 2.0 system is applied in the student residence at the University of Hong Kong, which is a modular construction project, involves 952 prefabricated modules, and all the modules are manufactured in mainland China and transported to Hong Kong by ship and vehicle logistics, and finally assembled at Wang Chu Kang. And there are mainly 5 major stakeholders. For example, the stakeholders and the clients, the main contractor, the manufacturer, and the authorized representatives. Well, in this these figures explain the working process of eInstar. Well, on the left part, figures with green borders represent the contractors uploading on-site inspection records according to the streamlined inspection processes. For example, user PY uploads 6 photos for the task number 5.3 for the module which ID is A-3F-21-M1-L, and invokes a transaction in the blockchain, and the offsite consultant approve or disapprove the record, and the result will be added as an endorsement of the transaction and published in the blockchain network. Well, in this system, the secret of maintaining the true provenance of data is utilizing IoT, which serves as the oracles of the blockchain system. The real-world data can be captured by eInstar by recognizing the outdoor or indoor IoTs. The near-field communication techniques guarantee the true provenance of data collection, but in practice, we also adopt QR codes as another choice for the cost reasons. And in this way, the real-world inspection data, such as photo records or video, can be captured and fed in the blockchain system in a trusted manner. And finally, the evaluation of the developed system includes 2 aspects. The first one is the system security and transparency. The permission blockchain network with granted access control by utilizing the certificate authority and the membership service provider guarantees the malicious attacks. And The relatively immutable data recording and consensus mechanism in blockchain transactions ensure the transparency of the quality assurance data. And the second aspect is at the industrial level. The e-inspection 2.0 system provides a feasible industrial level solution for remote trusted quality assurance activities. The QA functions, including inspection, the streamlined checking processes, are all supported by our system. And the practice in the student residence project gives empirical evidence of blockchain rebuilding trust in the construction industry. And IoT can be integrated with blockchain to feed the real-world data in a trusted way. And in the future, a more complex smart contract for the modular construction quality assurance should be developed to deal with the complex transactions, because now the inspection method is mainly focused on the visual inspection. For other inspection methods, such as the experiment, a variety kind of information should be considered. And in practice, we found some communication latency due to the cross-border communication, and this should be improved in the future. And this project is funded by the Hong Kong Innovation and Technology Fund, and there are 3 listed journal papers we published in the past for your reference. Thanks for your listening.
Well, thank you. Thank you very much. Okay.
Hi, Christine.
Are we able to?
Can you hear me now?
Yeah, we can hear you now.
Hi. Oh,
Great.
yeah. Thank you. Okay. So I think I should give a brief introduction to myself.
Sure, perfect.
First, thanks for Christine's arrangement, and I'm Lenin Kong, and also you can call me Carl.
Okay.
I'm from the University of Hong Kong, the real estate and construction, and my major research interest focus on the building information modeling. And let me start with you. Okay.
Yeah. Thanks.
Thank you. Oh, sorry. My major research interest focus on the building information modeling, the smart cities, and how these advanced technologies such as the IoT and blockchain and the information technologies can contribute to the construction industry. Yeah.
That's great.
Thank you.
Well, thank you. Thanks. So we have a few questions. We have about a minute and a half left. Does anybody in the audience have questions for you? No? Okay. Well, I'm going to ask a question. I wanted to ask, do you know if there is or what would you think would be a benefit from a decentralized versus a permissioned or permission versus permissionless blockchain for what you're working on here?
Sorry?
Would there be a benefit for a permission versus non-permissioned blockchain?
Yes, because for the construction project, we don't want other participants join the blockchain network. We only want the stakeholders, such as the owners and the designers and the constructors to join our network. And so the permission blockchain or the consortium blockchain is much more preferred in this scenario. And we want to utilize the access control provided by the permission blockchain. Yeah.
Okay, that's great. And then were there any things that you felt when you were doing your research that were negatives or because it seemed like that there would be a very that this would really help to make sure that the process has been on correctly and there was no tampering with the quality assurance and the logs and stuff like that. Were like, so they're all the benefits. Were there any things that you would see as like a disadvantage?
The disadvantage?
For the for having a system set up the way that you're talking about versus the traditional way of...
Yeah. Yes. I will explain more about the traditional quality assurance in the construction project. Construction project. Traditionally, the prefabricated modules are inspected or checked on site. You mean in the factory? For example, it's like a Lego building, a Lego building model. Yeah, and but due to the cross-border control, due to the COVID-19, especially in China, the cross-border communication become more and more difficult. For example, in our project, all the modules are prefabricated in mainland China, but they have to be checked. They have to be checked by the Hong Kong specialist. Okay. But we are not able to go to the mainland China now. It's very costly, and so as a distributed system, the blockchain can maintain maintain the trust, and can help people to achieve a long distance communication and to achieve a common agreement. Yeah.
Yeah, and a much quicker too. So there's really no disadvantage to using a blockchain permission-based system, it seems like. Okay. Yeah. Okay, well, I think that's enough for your time, and you did really well. So thank you very much.
Thank you.
And then we're gonna start on the next one. Hold on one second. I'm going to get the next one lined up here. Hold on. There we go. Okay, let me just okay.